I'm aware of time. We've got someone on the call who's in an airport who's presenting, so I'm aware of mindful of time. So if we just start, and then if anyone has any questions, please put them in the chat. If you can keep yourself on mute, but at the end we will also have time to ask questions with the Q&A. So yeah, when you're ready, please, can you start?
Yeah, sure. Hi, today I'm excited to talk about our recently run to the project. Our team is called ClimaTracks Solutions, and it aims to forecast resilience of a railway network under propagating uncertainty. So this is our team. So I'm Ji-Eun Byun from the University of Glasgow. We have Giuliano from the University of Sheffield, Cheng from the University of Birmingham, Irene from Montfort University, Tohid from University College London, and Konstantinos from Durham University. So so this project has been motivated by the fact that network rail is bearing increasing amount of loss due to weather-related disruptions. Then now the questions are, if we can better forecast weather-related disruptions of railway services, so that we can better warn before something happens, and second, if we can identify these weak links in a network system so that we can better design our network to be resilient to these local failures. And the key challenges that we identify are first, the data integration that have been collected with the diverse qualifications. And there is this high uncertainties in weather events as well as the failures of assets when they face this extreme weather event. And third, this uncertainty propagating through jointly performing assets. And finally, there is a lack of ready-use computational tools for decision-making on risk on railway services. So in order to address these key challenges, this is how our proposed solution looks like. So we are going to combine this data on weather, assets, and topography to set up probabilistic models of these components. And then we are going to use to infer the probabilities of these local failures. And then by employing system reliability method, we are going to propagate these local failures to the entire system so that we can understand the risks of the system level performance. So our first strategy is about using fragility and weather data. So we are going to use data in Anglia region. And first, we've got this historical rail delay records that have been collected by Network Rail for 10 years, which includes time, location, incident, causes, and delay minutes. And we also have this asset data about how the railways are located and connected. And we also have this data on line side vegetation coverage because it has previously been found that this vegetation condition affects the performance of individual assets. And finally, we have this weather data by 5 by 5 kilometers resolution, which includes temperature, wind, precipitation, humidity, and solar radiation. So previously, particularly our colleague Cheng from the University of Birmingham analyzes fragility and weather data so that to see if these causal variables can provide some reliable prediction on the probability of asset failures. And as input variables, they investigated gust speed, wind direction, temperature, humidity, snowfall, and precipitation. And they also looked at vegetation conditions. And they found out that quite expectedly, there's varying degrees of influences of these causal variables, either positively or negatively. And what we want to build on these previous findings is that how much in advance we can make predictions on failure of assets and how this prediction accuracy decreases with our in proportion to the prior time before the occurrence of an event, so that we can have an idea of how much in advance we can make a prediction and inform the railway service. And the second strategy is using this railway network simulation function. So previously, particularly our colleague Giuliano at the University of Sheffield developed this simulation function that simulates rerouting, and thereby they provide a more realistic measure of the unmet demand because of the asset failures. So so this algorithm performs iterations to reroute the unmet demand until there is no longer an available rerouting route. And so for this, they used this one of the maximum flow algorithms called Edmond-Karp algorithm, and they collected this demand and supply data from network rail, and they defined this residual demand as the total original demand minus the demand using damaged removed asset edges, and then plus demand rerouted to not use its damaged edges. So this is the metric that we are going to use to define the performance of a network system or railway system. And finally, we are going to apply one of the most advanced system reliability methods. So from the discussion so far, what we found out was that the previously shown algorithm belongs to the class of coherent systems, which means that better component states do not worsen a system state. So, and in this case, there is a recent algorithm that we can effectively decompose the event space. So thereby we can reduce the time and memory required for reliability analysis than, for example, brute force Monte Carlo simulation or AI methods such as using artificial neural networks as a surrogate model. So the idea is that if we know these failure samples, then this worst domain we automatically know that this worst domain belongs to failure domain. And if we know these survivor events, then we know that this belongs to survivor event. But in the case of a Monte Carlo simulation, we have to sample these already known domains as well, which is a waste of computation time. And even if we manage to do this Monte Carlo simulation, when there is a real-time data, for example, the data on hazard scenarios, and so we have these changed models of hazard scenarios, then in the event space, these samples change their locations. And then these MCS samples become no longer usable. But in the case of this analytical method of event space decomposition, then we can quickly update the probabilities so that we can compute the changed probabilities and inform on this real-time decision making. So so to implement this, we are going to adopt this MBMPI toolkit and modify it, which has been developed at the University of Glasgow by myself as a general open source tool for system reliability methods. So one of the example applications of the toolkit is this highway network subjected to seismic risks. And we performed this a priori decomposition, which took about a day. But then when it comes to real-time updating, by, for example, we now know the location of the epicenter, then we can quickly update the probabilities, which takes only 10 minutes. And then we can use this for emergency activities. So this is a technology that we're going to use for this project. So by these three strategies, the outputs that we are going to deliver on DAFNI platform are first from the point of data. We are going to focus on strong wind and heat waves, and we will upload this weather-related disruptions data set on DAFNI, and we will also evaluate this weather-related risk map of the Anglia region on the railway services, and then we will upload this on the DAFNI data platform. On the other hand, from the perspective of modeling, we will develop this risk mapping software written in Python and upload on the modeling side. So this is how the the plan of our model. So first, if users have their own data on the railway network, and then they will put this in the risk simulator, and they can choose one of the options that we are going to provide as a risk metric that they want to make decisions upon. And then there will be this visualization function that they can use to visualize the spatial distribution of these risk metrics. So the impact that we are aiming for is first, to facilitate this risk-informed forecasting of weather-related disruptions so that we can take preventive measures on any weather-related disruptions of railway services. And second, we are going to explore the effective use of massive regional data and network topology that are currently available in NetCore's database. And so we want to we intend to investigate what are the other possible ways to use this data. And of course, using DAFNI platform, we are aiming for this collaborative and continuous model collaboration so that a broader research and innovation community can come together to achieve ever more reliable railway services. And our plan is also by capitalizing on the project findings to develop a full nation scale project in partnership with the Network Rail as a follow-up project. So in conclusion, the problem that we are focusing on is this increasing weather-related disruption of railway services, and our aim is to develop this risk assessment tools as well as data compilation on railway network with a particular focus on system-level performance. And the strategy is that we are going to combine these probability models of weather and the fragility models of railway assets and the simulator of the railway operation and system reliability tool so that we can develop this ready-use risk assessment tool of a railway network, which will be all available on the DAFNI platform. And by doing so, we are trying to achieve this more resilient operations on railway networks, and also to facilitate this collaborative risk assessment tool to enable this collaborative risk assessment tool so that this tool can be applied for more general railway networks around the world. And thank you for listening.
Thank you, Ji-Eun. There's some questions just gone in, but we'll keep them to the end if that's okay. Or you can answer in the chat. Okay, team impact, are you ready to go?
Yes, I will share my screen. Wait. Can you see my screen?
It's just loading for me. Yep, there you go. Just need to go in presentation mode, please.
Yes, yeah.
Great, yep, all yours.
Yeah, thank you. Good morning, everyone. Today I will talk our impact projects. So it is improving flood disturbed road network resilience with dynamics, people-centric digital twins. And our projects included different universities and also different departments around the UK. So I'm from the University College London, the Bartlett School of Sustainable Construction. My name is Qiuchen Lu. I'm an associate professor there, and it's also covered Professor Tao Chen from the Department of Civil and Environment and Geometric Engineering. And we also appointed two part-time researchers. So who is Mr. Xuhui and Mr. Xianghui Zhang. And we also include two other support members from the University College London, the Tohid, and also Dr. Trent from the Cranfield University. And as we all know that climate changes is a very challenging issue around the world, and especially in the UK, we actually suffer more rain introduced for urban flooding than ever. So such as the A303 has been closed for days after a very heavy rainfall introduced floodings, and it is predicted that around 6,600 kilometers of UK road will be suffered to the floodings, and also it is anticipated to increase by up to 160% by 2080 if there are no specific or effective measures. So for these projects, we will particularly focus on the road networks around all the civil infrastructures, and also will propose a digital twin based solutions for specifically for London areas. And also, among all the risks, we will focus on the traffic congestion risk, as this is the most common risk to the road networks, and which is also an important part of accessing road network services, capacities, and also further for the road network resilience. And basic on the literature review we currently did, and also basic on the interviews we conducted with several departments within London, we found that currently majority of the road network, especially the resilience strategies, mainly focus on the static approaches or algorithms. So, and the majority of the road are only focused on the main road, other than treat the road network as a whole systems. And also, if we want to achieve such a kind of digital twin-based solution, it is cross-domain integration problems. So, for instance, we need to integrate the weather-based database and the traffic flow database, and also the road network structures themselves as a whole systems, and provide the necessary analysis for the whole city level based road networks. And also, when we consider about human involved into the whole system, it is multimodal based problems. For instance, we need to we need to consider and focus on different groups of people, such as the car, the bus, and also bicycle-based users. So this is a kind of people-centric assessment, and we need to include it and consider multimodal database. So this is the reason why we integrated and proposed such kind of projects called Impact, and we would like to develop the multimodal data-based dynamic people-centric digital twins. And the whole projects will integrated and have 4 work packages. So the first one, we will develop a layer-based data sets integrated with multimodal transportation data, including three groups, so the bus, bicycle, and the cars within the road networks, and also the weather-based data from the Met Office, and also the road networks themselves, based on the map, GIS, and other possible available data sets. And the second work packages will develop the user road flood data engines. We will evaluate and compare all the needed and available risk assessment method and approaches, and choose the most available one and practical ones for the case studies we use in London areas. So based on the current literature review and compare and evaluation method we did, so we will develop an integrated assessment approaches based on the static dynamics cross-grain approaches, and also the topological analysis methods. And the third work packages is to develop the dynamic people-centric digital resilience strategies for different groups, especially for the multimodal traffic recovery. We will cover 3 behavior groups. So the car, the bus and also bicycle users. And the fourth one is we will integrate the proposed dynamic people-centric digital twin with the data sharing strategies and with DAFNI systems. And we will verify the proposed systems through a London transportation case study. And here is a technical framework that we will use and propose for the whole project. So this project has been started at April the 1st. So 2 months already passed, and we have some very initial results about these projects. So firstly, we will have four work packages for the impact projects. The first 3 work packages will integrated and develop the proposed multimodal database-based people-centric digital twins. So the first work packages will develop an open semantic common data environment for the whole system. It will integrated the multimodal traffic data, the road networks themselves, the topological analysis, the Gs, and also other related the road networks themselves, database, and also the weather data from Met Office, and also the flooding simulation models. And the second work packages will integrate the proposed assessment model we will develop for the whole digital twin systems. It will integrate the 24 hours traffic flow dynamic analysis and is covered for the whole road networks, and especially will focus on the continuous raining days, such as the July and August during the summer, and also the Decembers and January, and which have very bad weathers, especially for 2023 and 2022. And we will analyze the whole road networks and combine with different systems. The work package 3 will provide the resilience strategies for 3 groups: the car, the bus, and also bicycle users within the London. So based on the proposed digital twin we will develop for these projects, we'll have 2 main output for these projects by the beginning of the next year. So the first one is we will propose the novel multimodal based dynamic people-centric digital twins, and it will have 3 modules: the user road flood data hub, that means the work package 1, the common data environment, and the second is the data engine based on the proposed risk assessment method, and the third is the user road flood resilience enablers. It was specifically covered for 3 groups. And it will also have a web platform demonstrator based on DAFNI systems, and also a real case study for the London areas road networks. And we also will have the novel user road flood data sharing strategies, especially for the multi-scale and multimodal traffic data. We will meet the DSIT challenges and solutions to the data sharing strategies. We will share the large-scale multimodal datasets for London area as the live implementations of DAFNI, and we will also share all the integrations, algorithms, mechanisms, and strategies for these impact projects. When we go back to what we raised at the beginning about the current research and implementation challenges, we will specifically focus on 3 aspects. The first one, we will focus on the dynamic strategies. So that means we will focus on the near real-time strategies based on the nature of the floodings and national hazards risk assessments. The second one is we will provide digital solutions for the cross-domain systems, which is the user road flood systems, and we will particularly focus on the multimodal and multi-resources data, so such as 3 groups: the bus, the cars, and the bicycle on the road. And the impact of these projects can be divided into different aspects. So it will not only focus on reducing the road maintenance and construction costs and improve the resilience efficiency, and we will also ensure the user's journey are predictable, reliable, safe, smoother, and open data. And we would like to save the cost and even lives during the environmental hazards. And For these projects, we will have a lot of foundations research results based on my previous research. For instance, we have successfully developed the carbon footprint digital twin for the highways in the UK, and which can provide a live and reliable digital solutions for the carbon footprint calculations of the highways. And we also collected and successfully constructed the stakeholder-driven common data environment for city-level urban management digital twins, which we are all used for this projects as a foundations researchers. And basic on the 2 months currently so far, we have hired and recruited 2 part-time researchers who will focus on these projects. We also finish all the data collections about the multi-hazard data residents in the London areas, and also floodings from Met Office, and also basic geometries of the London street data. And we also conducted the literature reviews and begin to prepare the evaluations and the comparisons of the assessment risk approaches, and also conducted the interviews. So this is the basic results and expectations in the future of impact projects. So please, if you have any questions, please feel free to email me or ask questions by the end of this section. Thank you so much, Katie. I will hand over it to you.
Thank you so much for your presentation. Yeah, the DAFNI programme, I'm really excited to see the outputs of the project. Okay, so last but not least is Fabian from the University of Cranfield. I can see you, Fabian, you're ready to share.
Perfect. Just checking that you can hear me okay as well.
Yes, all good, thank you.
Lovely. Well, hello everyone, and welcome to the final presentation of this webinar. So by all means, if the connection stops or you can't hear me, please feel free to interrupt, and then I will try to resolve the technical issues. But without further ado, so who are we? We are the team MARS, so it's for modeling aviation resilience scenarios. And we are a team of 3 researchers, all coming from Cranfield University. So although I'm the principal investigators, real credit is also due to Irene and Desmond, who are responsible for the technical implementation. And as it says in the title, what we really want to achieve is model flight diversions, especially the ones that are a result of the mass diversion event. So to give you a bit of background, I've just plotted all of the takeoff and landings at the UK. And as you can see, we've seen a lot of flight movements. Yes, there was a decrease during COVID times, but we are now back to 2018, 2019 levels. So as you can see, we have a lot of flights, over 2 million flights every year. That's roughly about 6,000 takeoff and landings every day. Why is it now a challenge? Well,
Fabian,
when you look at, yes.
Fabian, sorry, we can't see the screen. I don't know if you were just giving an introduction, but I can't see any slides at the moment.
I wanted to share.
It's all good. It's not showing at the moment.
Is it not?
It's loading now. There you go. Yeah, I can see the slide 5 background.
If I just try to go into full screen mode.
Yeah, I think it's, yeah, there you go. I can see it full screen. I
Hey.
can't see any others. There you go.
All right, just to give you, again, that's Irene, that's Desmond, and that's me. But I'm not sure if you will see the slides at the end as well, or if you can have a copy, but by all means, you haven't missed a lot. It's just what I talked about, the background here. It's about how the increase in flight movements affected the UK aviation system. So what I referred to was that we currently have 2 million takeoff and landings every year. So that's roughly about 6,000 a day. And the challenge really is created due to the lack of excess capacity at especially the London airport, but airports in general in the UK. So you can really see that we have highly utilized the system, which is good when we talk about efficiency. I mean, looking at London Heathrow, we run at close to 100% capacity. So it's a highly efficient airport, but it also means if there's any disruption caused by a technical fault or weather-related fault, or as we have seen during the 2018 Gatwick drone attack, where we have to close London Gatwick, it's a real challenge for the entire system. Because if you take out one of the airports, you have to land the plane somewhere else. And if you barely have any excess capacity at the alternate airport, that means you have to find new homes, and you have to find new homes for these planes quite quickly, because at some point they might run out of fuel. So that's really the background and the driving force for this project. The challenge is we have about 25 airports in the UK, commercial airports where you can potentially land these planes. But there are severe restrictions. First, when a plane takes off, it has to declare a first and second diversion priority. But as you have just seen, if all of the planes were to divert to the first and second declared priority, that's not possible because there isn't enough capacity. We also have stand availability at the other airports. And you can picture yourself or picture it as a car park, right? You have a few spots for buses, a few spots for lorries, and then a few for cars, and then some for motorcycles. You can park a motorcycle in a car or in a car in a lorry car park, but you can't do the other way around. And that's the same for airports. You have some stands that can take very big aircraft, and some for like the typical A320 or regional jets. The other bit where we talked about was the runway utilization. Heathrow, for example, can do 56 movements an hour or around that. And the real challenge is the contractual agreements. So if I'm, for example, British Airways, I can't land at all of the other airports in the UK because I don't always have contractual agreements. Meaning if I land, someone has to refuel me. Someone has to attach some stairs or steps. And I need a contract for it. And that's where the real challenge lies. We have a lot of exclusion criteria. So what we want to model is a computational complex problem. We have to define an algorithm that comes up with a solution where to put the planes efficiently. So when we talk about a 3-hour delay, and that's probably what we're going to do and simulate at Gatwick, we have to find alternate airports in the region of 90 for 90 aircraft. So what we've done so far, we looked at the flight plan. So that's a typical flight plan that if you file it, so it tells you what the time of arrival is, where it's coming from, and where it's going, and what airline it is, and what aircraft they're bringing. We then anonymize it just so we can access the data and also share the data. So instead of EasyJet, we have airline 07 or 01. So we would have the code to then trace it back, and it's also important to share the results with industry. So we can then go back and say, okay, you would have 7 EasyJet airlines at this particular airport, whereas for this research project, we would just anonymize it to airline 01 or whatever acronym we're going to use. We also want to convert the aircraft type. So I talked about the stand availability. So we will consider code E to code F. So code F meaning it's the biggest aircraft. So that's an A380, for example. A code C is a smaller aircraft like an A320. An example of the stands, what I talked about was the car park. So normally you would have fewer spots for the big aircraft like an A380, whereas you have quite a lot of code C aircraft types. So that's for the A320, so the typical aircraft you see that is used for the European market. Runway utilization, just an example. Again, we will take out some commercial sensitivity, but that just tells you that, for example, this airport is running 28 movements an hour, but potentially they could increase it to 34, meaning you could land 6 additional aircraft there. One interesting thing we've already come across during the project is the amount of operators there are in the UK. It was quite a surprising number. So far, we are working with 140 different operators. And what we've done, we looked at where those operators operate from. So we have a list. So it's a matrix of all the airports and all the airlines. And we looked at, okay, what airport does, for example, Aer Lingus operate from? Because that would imply that there's a contractual agreement. But for example, we come across one American operator and they only operate out of Heathrow. So that would mean that they would not have any alternate airport, just purely looking at their operational schedule. So I requested just a list of where they could potentially divert to. And interestingly enough, in the UK, no one has got this visibility of where could those operators potentially operate to. So in case of this American operator, although they only operate out of one UK airport on a day-to-day basis, they would have 7 other airports. So at the moment we are building also this database that is also quite valuable to industry and especially the regulator. So those are the criteria that we are working with and considering. So at the moment we are building the database, and then we are now in the process of starting the development of the algorithm. So just to give you an idea about the timeline, it's a 12-month project. So we are now in the first box, and we are already starting some of the data pre-processing. And that's at the moment my priority is to get the data set as quickly as possible to Desmond and Irene, so we can start with the development and then also share some of the preliminary findings back to industry. And we want to have an iterative process because we do rely on some of the industry data. And it's not that there's one person you have to talk to and you get all of the data. As I showed early on, sometimes you have to talk to individual stakeholders. So there's a lot of emailing back and forth between some of the airline operators, but I've also reached out to the AOA, so that's the Airline Operators Association. So that's the association for all of the UK airports in the UK, as it says in the title. So most importantly, what do we want to produce for DAFNI and the users of the DAFNI database? So we want to upload the data set that we're going to use. In order to get all of the data and share all of the data, we did decide that we want to anonymize it to the extent that it's still of use to you, but we might take out some of the commercial sensitivities, such as airline or the specific aircraft model. Irene and Desmond will be developing a model, and the documentation will be uploaded to DAFNI. I mean, that's also one of the things that Irene was very strong about, and DAFNI is also strong about, is sharing that algorithm, because that's the only way we can improve it afterwards, right? So it's scalable. It's not just meant for the aviation industry, and especially not just for the UK aviation industry. So our vision would be, once we've proven the concept for the UK market, we could also run it with a different data set for either the European market or other interested countries. Yesterday was also the workshop where we talked about some of the technical applications. We talked about Jupyter Notebook, for example. So that will be done through this platform as well. As I mentioned, the model can be adapted and extended, not just to other markets, but also to other modes of transportation, right? We do have exclusion criteria that we can change and adapt. So that would also be applicable, hopefully, for the train industry. But for this project, we focus on the UK aviation market and want to develop one scenario where we close one of the nodes and we would see what would be the optimal solution that the algorithm would come up with for diverting the planes. And that really concludes my part of the presentation. I think I have 2 minutes to spare, so I would probably hand it over back to you, Katie, so we have a bit more time for Q&A.
Great, thank you. Thank you for the presentation. It's cool to see the work that you've done so far since the start of April. I think there are 2 questions. Lindsay, do you want me to do these?
I don't mind. I think the first question may have been answered, but I don't know if Fabian wants to elaborate on it a little.
It says, is the project currently looking at UK flight diversions? If this is the case, can the project be expanded to include international flights, say Munich to Chicago, for example?
So Munich to Chicago, it would depend whether we would look at the American market. So if it's a flight to America, yes, America is obviously a lot bigger, so we would have to deal with a much larger database already. The database will be quite big. I mentioned that we have about 6,000 flights a day. So in order to limit the scope of this data set, we said, okay, we probably consider 3-hour closure. So we take all of the flights 1 hour before the closure and probably 2 hours after the closure. So we would upload a data set of 6 hours of flight. But again, our idea and approach, and we would have to see how the algorithm shapes up and what the specific characteristics are. But ideally, that would be scalable to other markets. So if we take a Munich-Chicago flight, that would be the American market.
Cool, thank you. I hope that answers your question. But please expand or ask another one if not. There's another question for Fabian. Is the algorithm about the diversion matching of operator and airport?
No, so that matching has been done by us before the actual algorithm would be developed. So what the algorithm is about, we close one of the airports that the aircraft wanted to fly to, and the algorithm would come up with the best alternate airport based on the 4 criteria that are presented.
Right, thank you. There's a question that's just come in for team impact. You mentioned the challenges and solutions to data sharing for the DSIP projects. Do you foresee any data sharing issues with this project?
Thank you so much for these questions and also for Katie. I just try to typing, but yeah, I can answer it here. So, so this is as I mentioned, this is cross-domain data sets and multi-scale data sets. So what I can say about data sharing is how to share such kind of data in an effective way, and also combine with the DAFNI systems. So so this is the main challenges we will see about these projects. We get training, especially technical training from DAFNI systems. So I hope that we can solve these problems when we get the specific training in this July. Yeah, thank you.
Thank you. There's another question for Mars team. What do you see the main challenge with the project?
I mean, we did the risk assessment. So the challenge, I wouldn't probably see it as, one of the things we were currently building the data set. So as I said, no one owns like this holistic view. So even looking at the stand availability of the different airports, that's a manual calculation we have to do to get the starting value. So building the data set and making sure that the data set, we want to have it as realistic as possible. That's why we rely on airlines also sharing some of their data with us. Otherwise, we have to go for an estimate, which is also good, but it would be great to get all of the real data. But as one of the contingency, as we already defined it in the proposal and risk assessment, we can build a data set ourselves. It's just a bit longer from the time. The main challenge, it's hard to probably boil it down to one. We all know when we code something, if it runs, that's great. Sometimes finding the mistake and debugging can be a bit time consuming. But so far we are comfortable and confident that all of the things we have identified in the risk assessment, we can control. And then that also applies to the challenges. So it's probably data availability, and then hopefully the code doesn't break once we run it with the whole data set.
Great, thank you. Yeah, because another one of your risks was getting the data from your partners, which you seem to have not had a problem with so far, which is good.
I mean, what I did, I went to Eurocontrol just to see what support they can offer and also what's their current thinking. And interestingly enough, I discovered that they have identified as a major issue because it's quite an obvious issue. So they want to build an operational tool, but our project would run alongside it quite nicely because we would do the simulation before something happens. And because Eurocontrol, as the entity they are, they're probably more placed in the operational. So that's why they're building an operational tool, whereas ours sits in the simulation. So hopefully we can also share some of the results with them, which hopefully proves to be beneficial and allows us to use some of the data as well.
Yeah, definitely. Thank you. There's just a question that came in, but I've seen you answered just for people on the live chat. There's been a question for team impact. Road user data and rain data is real-time data or pre-recorded data?
Yeah, I tapped the answers. So thanks for these questions. It's pre-recorded. So the rain data is downloaded and available from Met Office website.
Cool. And there's another question that just come in. What is the sources of the road user data and challenges to collecting such data? And is it sharing licenses from other agency?
Currently, the user data is from one of our collaborators from UCL, and we will find a way to share it at the end of this project and combine it with DAFNI platforms. So I think by the end of this project, there is a way to download it. Thank you for the questions.
Thank you. There's a project for ClimaTracks. When do you plan to upload the risk mapping software onto DAFNI?
I think it will be the end of project, which is the end of this year.
December, is that?
Yeah.
Yeah, cool. Thank you. I think that's all the questions. There were a few questions at the start for ClimaTracks, but I think you've answered them, haven't you, Ji-Eun, in the chat? So if anybody wants to see them, there's quite detailed answers. So I'll just check. I can't see any more open questions, so I'll just double check with people on the call. If you have any further questions, please let us know. Write them in the chat, or you can raise your hand and ask. But we will be sharing the presentations online, and you're more than welcome to get in contact with each team. So I'll wait another minute. I can't. Oh, there's one more question here for the Mars team. Will you incorporate the real-time stand availability data in your tool?
Okay, because of the scope and that would have to come. The short answer is currently there's no real-time stand availability as far as I'm concerned. So that's even Eurocontrol had to calculate that for the prototype they were doing for an operational tool. So whether they will find a way to include real-time stand availability in their tool, in their operational tool, I'm not sure, because we are simulating it. We will always have a set start stand availability in the way that we are doing it for the simulation. But it might be one of the ways that we could explore it for further analysis. So our algorithm is probably positioned somewhere else.
Thank you. I haven't seen any more questions come in now, but I'll wait a second. But yeah, thank you so much for our presentations today. They've been absolutely great. We're really looking forward to seeing the outputs on the DAFNI platform. All presenters will be presenting at the DAFNI conference in September, which we're also looking forward to, so you can follow the projects and see their progress there. We will be sharing an update on the DAFNI website with the presentations and the live recording, so you can look out for that. So thank you everybody for attending. I hope you found it useful and good that you've utilised the questions and the Q&A session. So with no more questions, I will end the call there. Hope everyone has a nice afternoon, and I look forward to seeing you at the next webinar. Thanks again, everybody. Bye now.
Thank you. Have a nice day.